We usually meet the speed of light as a number, 300,000 kilometers per s-econd, a figure memorized in school, printed in textbooks, repeated until it feels ordinary. Fast, yes, impressive, certainly, but still just a number, sitting politely next to others. Feynman warned that this is the first mistake. The moment we treat light speed as a quantity we could, in principle, approach or challenge, we have already misunderstood what it is. In everyday life, speed is simple. A car is faster than a bicycle, a plane faster than a car. Speed is something you add more of by pushing harder. Our intuition insists the universe should work the same way. If engines were stronger, if fuel were better, if technology improved enough, any speed should eventually be reachable. Light speed then appears as an engineering problem waiting for a solution. Feynman insisted this instinct is not just wrong, but deeply misleading. The speed of light is not a record set by light. It is not a limit imposed because nature ran out of power. It is a structural feature of reality itself. Treating it like a number hides the fact that it behaves nothing like other speeds. You can subtract from it, add to it, chase it forever, and yet it remains unchanged. No matter how fast you move, light does not slow down for you, nor does it speed up for someone else. That alone should tell us something is strange. Feynman often emphasized that physics becomes confusing precisely when we force familiar categories onto unfamiliar facts. Calling light speed a speed invites the wrong mental picture. It suggests motion through space in the ordinary sense, when what is really being described is the relationship between space and time themselves. Light speed is not about how fast something goes. It is about how reality measures distance and duration. Once you see it this way, the number begins to feel almost incidental, 300,000 kilometers. Per s-econd is not important because it is large. It is important because it converts time into space and space into time. It tells the universe how much distance equals how much duration. Feynman pointed out that if this number were infinite, time would be absolute and shared by everyone. If it were smaller, reality would fracture even more violently than it already does. So when we casually repeat the value of light speed, we lull ourselves into thinking we understand it. We mistake familiarity for comprehension. Feynman's discomfort came from noticing how easily humans accept symbols in place of meaning. Light speed is not a wall you crash into. It is a rule that reality obeys everywhere, quietly reshaping motion, causality, and time long before you ever get close to it. This is why Feynman treated light speed with a kind of intellectual caution. He knew that once a constant appears everywhere, in every equation, it is no longer describing objects, but the stage they appear on. We keep asking what happens at light speed, when the more dangerous question is what reality must be like for such a speed to exist at all. The number tempts us to think forward toward motion, while the truth points backward toward structure before anything moves, before anything changes. This rule is already there, silently deciding what can happen and what never will. That is why Feynman urged patience here, because misunderstanding this number does not merely confuse physics. It quietly distorts how we imagine reality itself, long before equations ever appear there. We talk about motion as if it were obvious. An object is here, then later it is there, and in between it travels through space. This picture feels so natural that questioning it sounds pointless. Feynman thought this was precisely the danger. The most misleading ideas in physics are not the complicated ones, but the ones that feel too simple to doubt motion, he argued. In everyday language, movement means changing position against a fixed background. Space is the stage, time is the clock, and objects slide across the scene. This picture works well enough at human speeds, which is why it survives unquestioned. But Feynman emphasized that physics is not obligated to preserve convenient stories. When light speed enters the picture, the idea of moving through space quietly breaks apart. The first crack appears when we ask a basic question: moving relative to what? In ordinary life, the answer seems trivial. Relative to the ground, the road, the stars. Yet physics offers no universal reference point. There is no absolute space, sitting still in the background. Feynman loved pointing out that if you remove every object in the universe except one, the question of whether it is moving becomes meaningless. Motion is not a property of an object alone. It only exists between objects. Special relativity sharpens this into something unsettling. If there is no absolute rest, then there is no absolute motion either. Every object can legitimately claim to be at rest in its own frame. This is not a trick of language. It is a statement about how reality behaves. Two observers moving relative to each other will disagree about distances, durations, and even the order of events, and both will be correct. The idea that something is simply moving through space collapses under this disagreement. Feynman stressed that we resist this conclusion because our brains crave a single, shared picture of the world. We want one timeline, one geometry, one story everyone agrees on. Light speed refuses to allow that because light travels at the same speed for all observers. Reality must compensate. Space and time adjust themselves so that the rule holds. Motion no longer means gliding through a rigid space. It means tracing a path through space-time, where distance and duration are inseparable. This is where intuition truly fails. We imagine speed as how quickly space is crossed per unit time. But near light speed, space and time themselves are observer-dependent. Different observers slice reality into space and time differently. Feynman liked to say that asking how fast something moves through space alone is already the wrong question. There is no universal space to move through. The discomfort deepens when we realize that nothing ever experiences itself as moving through space at all. In its own frame, every object is at rest. What changes is how other observers describe it. Motion becomes a relationship, not a process happening inside the object. This is profoundly counterintuitive, and Feynman never tried to soften it. He believed clarity required accepting how strange the answer really is. So when we imagine accelerating toward light speed, we picture an object racing through space faster and faster. Reality does not see it that way. What actually happens is that different observers disagree more and more about space and time, while the object itself remains calmly at rest in its own frame. It is happening to the structure of reality that connects observers to one another. This is why light speed is not an obstacle you approach by moving harder. It is the point at which our everyday picture of motion completely loses meaning. Feynman understood that the universe is not telling us objects move strangely. It is telling us that our idea of motion was never as solid as we thought, and light speed is where that illusion finally gives up. When people imagine approaching the speed of light, they usually picture engines straining, energy piling up, and matter protesting as it is pushed faster and faster. Feynman thought this image was backwards. The real drama, he explained, is not in space and not in motion, but in time itself. Long before light speed is reached, time quietly begins to fail. We treat time as a steady background flow. Seconds tick forward uniformly, the same for everyone everywhere. This assumption is so deeply embedded that we rarely notice it. Feynman often remarked that our confidence in time comes not from evidence, but from habit. At ordinary speeds, the differences are too small to notice, so time appears universal. Light speed exposes that assumption as an illusion. As an object accelerates, something subtle happens. To an outside observer, the object's clock begins to slow down. Not metaphorically, not approximately, but literally. Less time passes for it. This is not a mechanical malfunction or an observational trick. Feynman insisted that time itself is what changes. The universe does not allow everyone to share the same temporal rhythm once light speed is involved. The unsettling part is that nothing feels wrong from the inside. The object experiencing this slowing of time does not notice anything unusual. Its thoughts, processes, and internal events unfold normally. This is where intuition collapses. Two observers can disagree about how much time passed, and neither is mistaken. Feynman emphasized that this is not about perspective or appearance. It is about what actually happens. The reason lies in the invariance of light speed, because light must travel at the same speed for all observers. Reality has only two options: distort space, distort time, or do both. Time pays the heavier price. Events that seem simultaneous to one observer are no longer simultaneous to another. The idea of a universal now dissolves. Feynman found this especially disturbing because it undermines the most basic way humans organize experience. Approaching light speed does not cause time to slow in the usual sense. It causes time to tilt. Different observers carve space-time into slices, differently, each insisting their division is correct. Feynman liked to describe this as nature refusing to choose a preferred viewpoint. The universe preserves its laws, not our intuitions. As speed increases, the disagreement becomes more extreme. To an external observer, the moving clock slows toward a standstill. At light speed, time would stop entirely. But this is not something the object ever experiences. Feynman pointed out the asymmetry here. Light does not experience time at all, while everything with mass is trapped experiencing time precisely because it cannot reach light speed. Time breaking is what prevents the limit from being crossed. This leads to a strange reversal. We think light speed is a barrier because objects cannot go fast enough. In reality, objects cannot go faster because time will not allow it. The closer something gets, the less time it has in which to get any closer. The universe enforces the rule not by resistance, but by temporal exhaustion. Feynman believed this was one of the deepest lessons of relativity. Time is not an independent backdrop. It is a negotiable dimension shaped by motion. When light speed appears, time becomes flexible, personal, and observer-dependent. Our everyday certainty about time survives only because we live far from this limit. So the ultimate breakdown is not mechanical but conceptual. Engines do not fail. Matter does not shatter. Instead, the shared structure of time dissolves into multiple, equally valid versions. Light speed is not where motion breaks. It is where the idea of a single, universal time finally gives up, revealing that reality has been operating under different rules all along. Light does not behave like an object competing in a race. That is the intuition Feynman kept trying to erase. When we say light always wins, we imagine it outrunning everything else. But what actually happens is stranger. Light does not win by moving faster. It wins because reality rearranges itself so that light can never lose. The rule is simple and brutal. Every observer, no matter how they move, measures light traveling at the same speed. This is not a preference or a tendency. It is an absolute requirement. Feynman emphasized that once you accept this single fact, the rest of relativity is no longer optional. The universe must bend to preserve it. To make this work, space contracts and time dilates. Lengths shrink in the direction of motion. Clocks slow down. Mass becomes energy. None of these effects are separate phenomena. They are all bookkeeping adjustments reality performs to protect the speed of light. Light always wins because everything else agrees to change first. This is terrifying because it means reality has priorities, and human intuition is not one of them. We expect the laws of nature to describe what happens. Instead, they dictate what must happen. Feynman liked to point out that nature does not negotiate. If preserving light speed requires abandoning absolute length, absolute time, and absolute simultaneity, then those concepts are simply discarded. The deeper fear comes from what this implies about cause and effect. Light speed is not just a speed limit, it is the maximum rate at which influence can travel. Causes cannot outrun it. Effects cannot arrive before it. Feynman understood that without this limit, the universe would collapse into paradox. Events could interfere with their own causes. The future could leak into the past. So reality enforces order by enforcing light speed. It is not kindness, it is necessity. Light always wins because causality depends on it. When objects approach light speed, reality does not allow shortcuts. Instead, it stretches time and squeezes space so that causes remain safely behind their effects. What makes this unsettling is how impersonal it is. There is no mechanism pushing objects back. No force says stop. The universe simply refuses to provide a consistent description beyond that boundary. Feynman found this more disturbing than a physical barrier. You are not blocked. You are undefined. As speed increases, energy requirements explode, not because motion becomes harder, but because you are asking reality to violate its own structure. Infinite energy is not a practical problem. It is a logical warning. It tells you that the question itself has gone too far. Light speed is where meaningful questions about motion begin to break down. Feynman often reminded students that physics is not about satisfying curiosity. It is about describing what is allowed. Light speed defines the allowed shape of reality. Everything else adapts to it. That includes space, time, mass, and even the order of events. This is why light always wins. Not as a champion, but as a rule. A rule so fundamental that the universe will rewrite every other concept before letting it fail. Once you see this, the terror is quiet but lasting. Reality is not built for understanding. It is built for consistency. And light speed is the line. it will never cross. This realization changes how fear should be understood. The terror is not that we are small or slow or technologically limited. It is that reality itself enforces coherence without regard for meaning. Light speed is the quiet enforcer of that coherence. It does not explain itself, and it does not care whether we find it beautiful or disturbing. Feynman accepted this with unusual calm. He understood that the universe does not exist to be intuitive, it exists to be consistent. And once that is accepted, the unease shifts. We stop asking how to break the wall, and start wondering what kind of world requires such a wall to exist at all, quietly holding causality together, while everything else bends around it without protest, apology, or explanation beyond the fact that it works, and will continue to do so always, everywhere. This realization changes how fear should be understood. The terror is not that we are small or slow or technologically limited. It is that reality itself enforces coherence without regard for meaning. Light speed is the quiet enforcer of that coherence. It does not explain itself, and it does not care whether we find it beautiful or disturbing. Feynman accepted this with unusual calm. He understood that the universe does not exist to be intuitive, it exists to be consistent. And once that is accepted, the unease shifts. We stop asking how to break the wall, and start wondering what kind of world requires such a wall to exist at all, quietly holding causality together, while everything else bends around it without protest, apology, or explanation beyond the fact that it works, and will continue to do so always, everywhere. By the time we reach the end of this path, the idea of a speed limit should already feel inadequate. Speed was never the true barrier. Feynman understood that what light speed ultimately protects is something far more fragile: causality itself. The universe is not preventing motion. It is preventing logical collapse. Causality is the quiet assumption beneath every experience. Causes come before effects. Decisions precede consequences. Signals arrive after they are sent. We rarely notice this structure because it is so reliable. Feynman warned that this reliability is not guaranteed by common sense, but enforced by the deepest rules of physics. Light speed is one of those rules. Seen this way, the wall at light speed is not something you crash into. It is something you never meaningfully approach. Questions about going faster than light are not forbidden in the way dangerous actions are forbidden. They are forbidden in the way meaningless questions are forbidden. Feynman emphasized that physics does not answer questions that cannot be consistently framed. This is why attempts to imagine faster than light travel always drift into paradox. Messages sent into the past, effects preceding causes, observers disagreeing not just about measurements, but about what happened at all. Feynman recognized these not as speculative curiosities, but as warning signs. They signal that the conceptual ground has given way. The unsettling conclusion is that reality is structured less like a playground and more like a tightly constrained system. Freedom exists, but only within boundaries that preserve consistency. Light speed is one of those boundaries. It is not negotiable because causality is not negotiable. This reframes our relationship with knowledge. We often assume deeper understanding means discovering hidden mechanisms behind limits. Feynman taught the opposite lesson. Sometimes the deepest understanding comes from recognizing which limits are not hiding anything at all. They are fundamental constraints, woven into the fabric of how reality stays self-consistent. The wall, then, is not an obstacle to be overcome by intelligence or technology. It is a condition of intelligibility itself. Without it, explanations lose meaning, prediction fails. Memory, responsibility, and choice become unstable concepts. Causality is not a feature layered on top of the universe. It is the skeleton holding everything else together. Feynman accepted this without mysticism and without comfort. He did not try to soften the implication. The universe is not obligated to allow every imaginable possibility. It only allows what can exist without contradiction. Light speed marks where contradiction begins. This is why the limit feels so final. It is not guarding distance or duration. It is guarding order. The past must remain the past. The future must remain open but not influential backward. Events must fit into a consistent narrative, even if that narrative is fragmented across observers. In the end, the most disturbing realization is also the quietest one. Reality does not break at light speed. Reality is saved there. The wall exists not because the universe is restrictive, but because it is coherent. Feynman saw this clearly. The speed of light is not the edge of motion. It is the boundary beyond which explanation itself would unravel. And once that is understood, the question is no longer how close we can get to the wall, but how much of reality depends on it, standing exactly where it does, invisible, absolute, and utterly indifferent to our desire to go further.